This is a demonstration of the Forest Manufacturing optional precision table tracking for our powered table drive systems. This machine today is the model 480i. It's a horizontal blade traveling table bandsaw. As standard, these come with a variable speed powered traveling table. This has the upgrade to precision table tracking. The standard table drive uses hard urethane casters running on 3-inch square tubing to serve as both the rail, weight support, and guiding element. So we have bearings that track along the tubing. It gives a pretty good ride. The urethane wheels give a fairly smooth ride, tracks about as straight as the tube will run straight. The wheels do have a little bit of compliance to them, and because they are urethane, they can be damaged. And they're good, but they're not perfect. And perfect, if you've been in this business for a while, you know, is pretty much linear round rail. So this upgrade switches from the urethane wheels to linear round rail as the guide and support elements. So this is a pretty good sized piece of equipment for round rail, so we have a few tricks to make it work. First off, about the table drive system. The table drive system still uses our toothed timing belt as the driving element. We have a motor, and I'll do a little walk around later on. We have a motor down here driving a tooth sprocket for the belt. This is a H200 section belt. The belt is urethane with steel reinforcing wire, so it's actually quite stiff. Idler rollers on both sides, and then it anchors in the center to the table here. The tooth timing belts have a couple of advantages. First off, they're cost effective. Particularly for something as long as this. If you tried to use ball screws or something for a table stroke like this, which is about, I think this is like a 7 or 8 foot table stroke, that gets to be a big expensive ball screw real fast, and supporting it over a horizontal span is tricky. So the timing belt is a cost-effective solution, and it's also relatively impervious to dust, debris, most misalignment. It's just a nice, tough solution for what we're doing here. So we use it either with the casters or with linear bearings. The linear bearings here I have mounted, we are not using the typical recirculating ball type pillow block bearings. Like you probably see them, they're real. Thompson's the well-known example of them. Very smooth, but they're a little delicate. If you get dust or debris or crud into those recirculating ball type pillow blocks, they die. And bandsaws are really good at making dust and debris. So what we use instead is I think the trade name is Freelon, but it's basically, instead of the roller element, it's a sliding element. It's a Teflon impregnated ceramic material that's sliding on this round rail. The coefficient of friction is higher, but it's a very smooth running piece, and it's impervious to dust, grease, oil, pretty much all manner of abuse, which again, the bandsawing environment is really good at dishing out. Alignment issues. This machine, we're gonna ship with a table fully assembled. We'll take it out of the saw part, but the table is gonna ship fully assembled so the customer doesn't have to realign everything. We do hold alignment here. We've got jacking screws of 4 points along the width here and end blocks to help it hold alignment, but we also have a floating side. So over here on what we call the drive rail, these bearings are hard mounted to the table. On the opposite side, where the limit switches are, they're mounted with a little bit of play. We have it's a captive system. They've got about plus or minus 1/8 inch of play with a Delrin plastic sliding element in there, so it's not going to wear out. Otherwise, you are trying to hold couple thou tolerance across 3 feet and 192 inches of length. Just not practical. This gives you all the straightness of travel and the true smooth action, but this is effectively the guiding rail. That side, if for whatever reason it winds out a little off, we're still good. No. What else do you need to know? Okay, the machine does have travel limit stops. I'll go ahead and run it forward. So we've got mechanical arm limit switches here. A little old school, but it works great. Everybody understands it. So it's pretty simple. Table travels forward. I have the skin off this table right now, by the way. So you hit the limit switch, stops, same in both directions. I currently have this machine set up at a maximum 2 inches per second travel speed based on a motor speed of nominal 1800 RPM. We're running it with an inverter, and the table drive motor is an inverter rated up to 6,000 RPM. So we could conceivably run this machine as fast as 6 inches per second. We're controlling the acceleration and deceleration profiles on this. So we accelerate from 0 to full speed at 60 hertz in 5 seconds, which is gentle. And we are decelerating from 60 hertz to 0 in 1.3 seconds, which is a little more aggressive. So when you hit that trip, we decelerate rapidly. If, for whatever reason, you decide you want to increase the maximum speed of the motor, say you want to run the motor at 120 hertz, you can certainly do that. The one thing you will need to do, though, is move the trip stops. Right now they're set up to get full travel, but they're set up to get full travel, trip, decelerate, stop. If you're moving at a higher speed, you'll need to move these trips a little bit further inboard. And they're mounted on easily adjustable tracks, so if you want to change the start-stop positions, that's easy to do. Otherwise, this is a pretty standard model 480i, horizontal blade traveling table bandsaw, using our basic controls, saw start and stop, controlled here. There's a brake motor running the saw blade. We have pneumatic tension and detention. We do have motor fault and blade fault lights. If you trip out either the motor overload for the brake motor, table drive motor, or the table drive motor, you get a fault condition, stops everything. If the blade breaks, or if you don't have sufficient air pressure, the motor either will stop or not start. Over here, table forward reverse are controlled with separate buttons and table stop, and I have 2 separate potentiometers, one for forward speed and one for the return speed. What typically happens is, once you build familiarity with the machine and what you're cutting, you'll find that you want to cut at something like 20 or 30% of full speed going forward, but when you return the table to the home position, you want to run at full speed. So you don't want to have to be adjusting the potentiometer back and forth every time, so you have one potentiometer for the forward speed, one potentiometer for the return speed, and that one usually stays at 100%, while the potentiometer for the forward speed, cutting direction, stays at whatever your magic happy speed is. I'll give you a quick walk around the machine right now. Sorry, my camera is not equipped with image stabilization, so this might be a little shaky. This machine, right now the table skin is off. We are using a piece of 1/2 inch thick aluminum mill plate as a table surface here. Again, normally we use fabricated steel, which is flat enough for most surfaces, but the aluminum mill plate is just dead flat, solid, easy to work with. Your control panel. Inside the control panel, my panel builder does a very nice job of assembling these things. Table drive mechanism. We got a couple of little details to finish on this machine. We have to fabricate and mount up a guard for the drive elements and the blade V-belt. Other than that, this is a complete machine. So again, that is a demonstration of a Model 480i with the precision tracking powered table drive. If you have any questions, please feel free to call us at Forest Manufacturing or send us an email. Thank you.